5.10, rotate an angle through a point. You're still finding the angle. We represent it with the Greek symbol theta. They're going to say that the angle's in standard position. Remember, that means that one ray's here on the x-axis, and then it's opening up counterclockwise, and it'll give you a point. On Delta Math, you'll have to plot the point. I just screenshotted it from this. And so here's our angle, theta. What we want to think about is how could we solve for that angle when this isn't something on the unit circle? Well, we've been learning that we're doing inverse trig. And so I've got the point at 4,7. Think about if you wanted to do sine. Let's say sine of our angle theta would have to equal the y value 7. I would have to inverse sine of 7. It says error domain. The problem with that is, if you remember from our last unit when we graphed functions, trig functions, sine function goes like this, over and over and over. It only goes from -1 to 1, of course, unless there are transformations, you know, the amplitude changes, but normally it goes -1 to 1. So this 7 is outside of that domain. It's not possible. And so we can't use that. We can't even use cosine of theta being 4, because that's bigger than -1 or 1. So what you're always going to have to use is a tangent ratio. Remember, tangent of an angle is y divided by x. So our tangent of this problem is going to be 7 over 4. We'll inverse tan that. And we get 60.3. We're in quadrant 1, so that is our angle. Okay, number 2 does not take place in quadrant 1. That's the only difference. We have our angle theta, standard position. The point 3, -6 is on the terminal side, so you go right 3 down 6. What is theta to the nearest tenth of a degree? So again, we can't use 3 or -6. Those numbers are too big to do on our calculator. So we'll have to make a tangent ratio of y over x. It'd be -6 over 3, which I'll simplify. That divides to make -2. We're going to inverse tangent, -2. Oh, I didn't want to do negative, really. I mean, it could. It's just going to get the positive version. And so our reference angle is 63.4 degrees. But again, being down here in quadrant 4, remember that angle applies here. To find where this ray's at, to go around here, we're going to take 360. Oh my goodness. 360 minus the reference angle. And you get 296.6. And that's it.